Philippine Mathematical Olympiad 2022, 24th round, and day 1 problem number 4, national stage written phase. Okay, so for having next videos, noticing, subscribe, turn on the bell, like the videos, and if you wanted any hint or anything, you can send message through my WhatsApp number. Okay, let's see the problem says what. Let triangle ABC has incenter I and centroid G. Suppose that PA is the foot of the perpendicular from C to the exterior angle bisector of B, and QA is the foot of the perpendicular from B to the exterior angle bisector of C. Define PB, PC, QB, and QC similarly. Show that PA, PB, PC, QA, QB, and QC lie on a circle whose center is on line IG. Okay, so before solving this problem, we would consider two lemmas. The first one is in a triangle ABC, AD is an altitude. You draw two perpendiculars from D to AC and AB, and the feet are x and y respectively. We want to prove that B, Y, X, and C is cyclic B, Y, X. See this quadrilateral. So if we connect x, y, we want to prove it now together. So if this is alpha, then you can say also because a y dx is cyclic. Because this is 90, it is 90, sum of opposite angles equals 180. So we can say if it is alpha, it is also alpha. Now we know this angle is what is, because in this triangle ABD it is 90, so it is 90 minus alpha. Also, we can say this angle is 90, so this angle is what? 90 plus alpha. As you can see, these opposite angles, sum of them equals 180. 90 plus alpha plus 90 minus alpha equals 180. So we proved that BYXC is cyclic. The next thing we want to prove is this, is that PQLR are collinear, these 3 points. Suppose that we have two arbitrary lines. We draw perpendicular from each point to these two lines, and we want to prove PQL are collinear if and only if x over y equals z over t. At first, we consider they are collinear and prove this ratio is satisfied, this equality. So if we connect, we know they are collinear PQL, and if we draw perpendicular to PX, we know these three lines are parallel because all of them are perpendicular to this line. Similarly, we can say these three lines are parallel. So if we draw perpendicular from P to this, then here we have rectangle. So this length equals also Z, this length equals also T. Here X, here Y. So we can say by Thayer's theorem, PQ over QL equals X over Y, and also PQ over QL equals Z over T. So we proved from this left to right. Now let's prove from right to left. So we consider from left to right a star and we use it, and we want to prove by contradiction. Suppose we assume on contrary the PQL are not collinear, so we connect PQ and we consider that it connects this line on L prime. Now, if we draw perpendicular from L prime to this line and consider this length is T prime, okay? So, because of a star, we know that if we have three collinear points, then the ratios are equal, so you can say, okay, because PQL prime are collinear, so x over y equals z over t prime. And since by the assumption here, we know that z over t equals x over y here, z over t prime equals x over y by star, so z over t equals z over t prime. So we can conclude t equals t prime, and because of this, we've reached contradiction. So we proved if these ratios are equal, then PQL are collinear. Now, let's solve the problem. Here, if we consider ABC and IA, IB, IC, this triangle, we want to see corresponding things. For example, the first thing we want to consider interior angle of ABC, interior angle bisector. So for example, this line, because this is interior angle, so here it is half of this angle, interior, and it is exterior angle bisector, it is half of this. So we know sum of this angle plus this angle is 180, so half of this plus half of this is equal to 90. So we can say AIA for ABC is angle bisector, internal angle bisector, but for this triangle IA, IB, IC, it is altitude. Now the next thing, we know AIA is internal angle bisector, so if you draw for BIB, CIC, their intersection would be what? I in center of ABC. But these lines are altitudes for IA, IB, IC, so their intersections would be H, orthocenter. Now, the vertices of ABC are what? Are the feet of the altitudes. And a triangle ABC, if you consider, is orthic triangle because we connect the feet of the altitudes in IA, IB, IC. So we wanted to just consider these corresponding points. Now we can change the problem to what? We can consider, for example, this one A, consider this one, for example, C, this one B. So it means that we draw altitudes and then these altitudes, and we want to prove that these 5 points are cyclic, and also we should prove the center. It says, the problem says lies on IG, this line. We know I of ABC is H, orthocenter of this line. And okay, we should prove in this case, if we consider this case, we should prove these 6 points. For example, these 6 points are cyclic, and the center lies on line H, and G centroid of DEF, because DEF here is like ABC corresponds to that. So let's now consider in the new figure. Here, I want to prove at first these 6 points are cyclic. Let's see what can we say. This angle is what? This angle is a y. Let's consider. We know this figure, this quadrilateral is cyclic. Why? Because this is right angle, this is right angle. Two right angles see the same side. So we can say it is cyclic. Now because it is cyclic, it is A. So we can say it is also A. Again, we can say this quadrilateral is cyclic. Why? Because it is 90, it is 92 altitude, see the same side. So because this angle is A, so this angle is A. So we proved this part. Now, we know that this quadrilateral is also cyclic. Why? By the first lemma. By the first lemma, let's hear. We said it is cyclic by lemma 1. So because that is cyclic, this, so it is B, we can also prove B. Now, we found this is B. This is A, because sum of them is 180, so we can prove it is also C. Now, we use this and we want to prove, because we have many things, because at first we want to prove PB, PC, PA, QB, QC, QA are cyclic, we only use the things that we need in the next figure. So, we said ACB. Similarly, we can say it is BAC, you can prove in this figure, and then here BAC, CBA, CBA. Now, ACB here. We want to prove these points are cyclic. So let's consider. We know it's C here, for example, this one. Let's consider at first these 4 points. Because this is C, this is C, they see the same side. So these 4 red points are cyclic. Now we consider 3 of them. And if we consider this one, it is C, it is C. Or you can say it is A plus B, C, sum of opposite sides, sum of opposite angle equals 180. A plus B plus C is 180. So these 3 points, we know that if we draw circumcircle of these 3 points, it passes through this and also this. So these 5 points are cyclic. Now, if you consider this point, this point, this point, for example, and this point, it is B, it is B. 2B, C, the same side. So we can say that this new point lies on the circumcircle of this. So we prove these 6 points are cyclic. Now, the thing that is left, the sentence that is left is why their center lies on the spatial line H and G prime centroid of FED. So let's prove it by lemma 2 that we've learned. So here, if we consider G prime, if we draw perpendicular from this, if we draw from perpendicular from O to this point, and if we draw perpendicular from H to this, we want to find the ratio dg prime to g prime m. Now let's see what can we do. Here, if we consider dm, let's see dm equals what? dm equals mqc minus dqc. Okay, so mqc, because we know it is from center of this hexagon we draw. So if we draw, we know it lies on perpendicular bisector of this line segment QCQB. So we can say that M is midpoint of QCQB. Now we say DM is MQC minus QCD. Now MQC equals what? Half of this, because it is midpoint here. So here you can say MQC is QBQC over 2 minus QCD. Now let's find DG prime. DG prime is DF prime minus F DG double prime, DG double prime equals DF double prime minus F double prime G double prime. Now let's see what can we say. DF double prime, let's focus on this. DF double prime equals what? So if you consider by Thayer's theorem, we know they are perpendicular, they are parallel, so you can say df double prime over dqb equals this over this, and we know it is midpoint because g prime is centroid of fde, so we can say that df prime is half of dqb, like here. And the next one, f double prime g double prime, f double prime g double prime, we can say it equals what? So if you pay attention, it is 1/3 of here. So also if you draw perpendicular here, it is 1/3 of here, and this one is 1/3 of here. So G double prime F double prime is 1/3 of QC F double prime. And now, if we consider this point Q, let me write. Okay. So if we consider it is Q, it is also Q. Why? Because we said it is half of this, and these two lengths are equal. It is parallel, so also these two lengths are equal. So if one of them is Q, the next one is also Q. Let's consider this one W. So dQB. dQB is what? Q plus Q, 2Q over 2Q, minus F double prime QC. F double prime QC is W. Let's see, is W plus Q over 3. If we consider common denominator, it would be 3Q minus Q, 2Q minus W. Now let's find dm. dm is what? QBQC over 2. QBQC over 2 is 2Q plus W over 2 minus QCD. QCD is what? W. So it would be 2Q plus W minus 2W, 2Q minus W over 2. Now if we divide dg prime over dm, 2q minus w over 3, 2q minus w over 2. We can cancel 2q minus w, it will be 1 over 3 over 1 over 2, which would be 2 over 3. Now, dg double prime over dm is this, dg double prime over g double prime m, you can consider it is 2, 3 minus 2, it's 2 over 1. Now, we can see that dg double prime over g double prime is 2. So it is not related to a, because we've done for BC. So if you do exactly the same thing for example, the next side like this, then again the ratio would be 2. And by lemma 2, we've proved that these 3 points, center of this hexagon, edge, and centroid of DFE, they are collinear. And finished.